Alrighty, so in this video, I'm going to go through the solutions for the IB Economics Higher Level Paper 3. This is the 2024 May paper. Okay, let's get started. Right, so by the way, I'm just going to do question 1 in this video, question 2 I'll do in the second follow-up video. So in the first question, we've been told to, or rather the first part of question 1, we have this table, and it's the balance of payments for Chile in millions of US dollars in 2021. Okay, so what do we have to do? Well, in part 1, we're told to calculate Chile's current account balance for the second quarter of 2021. So where is the second quarter 2021? Well, second quarter is essentially everything in this column over here. So we're going to be looking only at the figures in column 2. Now, the current account balance is equal to your trade balance plus net primary income plus net secondary income. So where do we get that from our table over here? Well, we get the current trade balance from the first two columns, from the first two rows, balance and trade included services, and then we get the net primary and secondary income from these third and fourth rows, which is income and current transfers. So essentially, we're going to get these 4 figures over here, which is the 4,665. minus 2,602, minus 5,015, minus 243. So that's going to be our current account balance in in the second quarter of 2021. Right, so here we've got as I mentioned, the balance in goods, the services balance, the income balance, and our current transfers, which is equal to 4665 minus 2602 minus 5015 minus 243. And if you mash those buttons in your calculator, you're going to get minus 3,195 million US dollars, which is $3.2 billion in deficit. So to answer the question, I find it's good practice just to, if you have the space for it, to provide like a 1-sentence response. So we were asked to provide the current account balance. So I would say the current account balance in 2021 quarter 1 is minus 3,195 US dollars, which is a deficit. Okay, so that's pretty nice and easy. It's just 2 marks, really, just sort of knowing which bits of this table to pull figures from. And yeah, so for the current account balance, it's just those first 4 rows, which is your goods and services balance plus your balance in income and your balance in current transfers. Okay, the second part of this question is asking us to calculate the financial account balance. So here you go. So we need to do the financial account balance for the 4th quarter of 2021. So, they're not asking us to do the financial account balance. They're giving us the financial account balance, and they're asking us to calculate the change in reserve assets, which we're going to do in a second. Okay, so they want 4th quarter 2021, which is going to be everything in this final column over here. So that's the column we're going to deal with, column number 4. So the financial account balance is going to be equal to all this stuff over here. So it's going to be a foreign direct investment plus foreign portfolio investment plus official borrowings and any kind of change in reserve assets. So that's the financial account balance. Now, what they've done here is they've blacked out this bit over here, the reserve assets, and that's the thing that we're actually going to have to calculate. Now, we're told that the financial account balance is equal to 7,552 million US dollars. So we're going to start with this equation. We're going to say, okay, the financial account balance is going to be equal to net FDI plus net portfolio investment plus net other investments and net reserve assets. So the financial account balance, we've been given this, it's equal to 7,552. Then for the net FDI, if you look over here, it's minus 3,897. For the net portfolio investment, it's 2,390. And for official borrowing, it's 6,053. So we just fill in those 3 figures, minus 3,897, plus 2,390, plus 6,053, plus the reserve assets. Now, all we have to do is just kind of do a bit of algebra. So we go 7,552 so if we add those first 3 bits of the equation, net FDI, net portfolio investment, and net other investments, if we add them up and then we just subtract them from the FAB, from the financial account balance, we should end up with the reserve assets. So that's what I've done in this next row over here. We say 7552, which is the financial account balance, and then we subtract all that stuff that was on the right hand, that were the first three items on the previously right hand side of the equation. We're going to end up with 7552 minus, and then you open the bracket, minus 3897 plus 2390 plus 6053. So I'll leave it up to you to decide how you want to do it in the calculator. You can do everything in the bracket, or you can, multiply out the negative signs if you want to, whatever works for you. So essentially, if you have, let's say if you add up all the stuff in the brackets, you're going to get 4546. So we have 7552 minus 4546 is going to give us 3,006. So the net reserve assets in 2021 to quarter four is going to be $3,006 million US. Now here they're asking us to state whether the reserve assets have increased or decreased. I'm not sure what they're asking, because increase or decrease relative to what? So if they're asking, has it increased or decreased relative to quarter three? Well, the reserve assets in quarter three were minus 8684. So if you've gone from minus 8,006 to plus 3,000, then yeah, I'm guessing that's an increase, right? So, but without any further clarification, we can't really say whether it's an increase or decrease. I'm guessing it's relative to third quarter. If that's the case, then you would say it has increased. But yeah, without further clarification, it's just not possible to actually answer that question. So I think that's on them, and they haven't written the question properly. Okay, anyway, that's done. So let's move on to the next part over here, which is on salmon farming. Okay, so let's have a quick read. Salmon farming in Chile. Salmon is Chile's most important food export. The value of salmon exports increased sharply in 2021, largely due to a recovery in the world price of salmon. There's boosted economic activity and employment, creating opportunities for entrepreneurship and regional development. Figure 1 illustrates the market for salmon in Chile. D is the domestic demand for, and SD is the domestic supply of salmon in US dollars per kilo. PW is the world price. PW1 is the world price after an increase from US $5.20 to US $8.40 per kilo. Okay, and down here we have this diagram which shows us, exactly what they've said. You've got all the demand and supply and all that sort of stuff. And what I've done is I've just kind of made these little annotations, like over here, I've got like A, B, C, and all that sort of thing. You'll see why I've done that in a second. It's just to make the analysis a little bit. Sorry, just a little bit. It's just to make the analysis a little bit easier when we eventually come to this. All right, so let's go back. Let's go back down to the question. Right. So what do we have to do? Well, in part 3, using figure 1, calculate the change in domestic spending. So here we have to change in domestic spending on salmon in Chile as a result of the price increase in the world price from US $5.20 to $8.40. So essentially, my strategy here, or what we're going to do, is we need to figure out what the spending was before the price increase, so at $5.20, and then we need to figure out what the spending is after the price increase at $8.40. And then we just take the change, right? So we take the after spending and we subtract the before spending, and that's going to give us the change in spending as a result of that price change. Okay, so let's go back up to the diagram. Try to get this in focus over here. Okay, whatever. So here is the before price at $5.20. And so the total amount of spending at $5.20 would be, so at $5.20, if we go to the demand curve, we can see that we're going to be at point E over here. So the price is $5.20, and we would be spending Chileans would be consuming 170 million kilograms of salmon. So the total spending would be essentially this kind of rectangle over here. If you can kind of see, I'm trying to make it as, I should probably find a different color. That's the rectangle. That represents the total amount of spending, which is the area D, E, F, and H. So now you can see why I sort of made those little annotations. It's a little bit more useful. if we're trying to explain where the different bits come from. Okay, so spending before is area DEFH, which is, if you look at the height of the triangle, or if you look at the base of the rectangle, it's 117 million multiplied by the height, which is $5.20. So the total spending is $884 million before the price increase. Now, after the price increase, when it's gone to $8.40, okay, so at $8.40, now this is the new price. And if you go to the demand curve, that's the total amount that's going to be spent. So if we go down over here to the horizontal axis, you see that 90 million kilograms would be spent by consumers, would be consumed by consumers. And so total spending would be equal to this rectangle over here, which is equal to area BCFH, right? So it's going to be, it's going to have a base of 90 and a height of 8.4. So we just got to multiply those two things, and that's going to give us the total amount of spending after. So the after spending is going to be $756 million. And so the change in spending would be the after, which is 756, minus the before, which is 884. So 756 minus 884 will give us minus 128 million US dollars. And again, if you have space, it's good practice just to provide just a little short, one sentence answer, which I've done over here. So I've said the change in domestic spending is minus 128 million US dollars. That's it. 2 marks. Yeah, pretty self-explanatory where they come from. Okay, this next bit, part 4, I think. Sorry, let's zoom a little bit. Using figure 1, calculate the price elasticity of demand for salmon in Chile when the world price increases from $5.20 to $8.40. Okay, so here we're going to do an elasticity. Personally, I think the elasticity formula that they've used is not quite correct, because they've used this thing called straight percentage change, whereas I prefer to use the midpoint formula, which is a more accurate version. But anyway, I think the way it's taught is that you just use the straight percentage change method. So I'm going to go with the version that's commonly being taught out there. Okay, so to calculate elasticity, we take the percentage change in quantity and we divide it by the percentage change in price. Now, the percentage change in quantity would be up here, it's Q2 minus Q1 divided by Q1 using the straight percentage change. If you're using a midpoint method, you'd select a different version. And the percentage change in price would be P2 minus P1 divided by P1. Okay, so now we've got to fill in the blanks. Let me just use a different color over here. So here we've got to figure out which one is P1 and which one is P2. Well, P1, I would assume, is going to be $5.20 because that's the original price. And P2, I would assume, is going to be $8.40 because that's the new price. So we're going to figure out the corresponding levels of demand at P1 and P2. So at P1, $5.20, Q1 is equal to 170, right? So I hope you can see that over here at 520. So if you walk over to the demand curve, quantity 1 is going to be 170. It's going to be 170. And at P2, which is $8.40, go back up over here. So at $8.40, you can see that spending would now be 90. If we go across to the demand curve, and I'm just going to go down there. I hope it's clear. So Q2 would be $8.40. Sorry, would be 90. Okay, so now we've got P1, which is $5.20, and Q1, which is $1.70, P2, which is $8.40, and Q2. Oh, shit, what have I done? Sorry. Q2, beg your pardon. Going to be 90. So we just substitute those values into the formula. So Q2 is 90, Q1 is 170. So we've got 90 minus 170, which is what I have over here. And then we're going to divide by Q1, which is 170. So that's going to give us the percentage change, which in this case is minus 0.4706. So we've got a 47.06% reduction in quantity demanded. Then we do the same thing for prices. So P1 is going to be $5.20 and P2 is going to be $8.40. So substituting them to the formula, we got $8.40 minus $5.20 divided by $5.20. And in percentage terms, that's going to be a 61.54% increase in price. And then we just divide one over the other. So if I go minus 0.4706 being the percentage change in quantity, divided by 0.6154, which is the percentage change in price, we end up with an elasticity of minus 0.76. And again, if you got the space for it, it's good just to write out the answer. So I'll say here the elasticity of demand is minus 0.76. That's it. So a couple of marks, probably one for getting the formula right and putting all the numbers in place, and probably a second mark just for doing the actual calculation correctly. Okay, let's move on to the next bit, part 5, I beg your pardon. Using figure 1, calculate the social/community surplus in the salmon market in Chile after the increase in the price of salmon from US $5.20 to US $8.40 per kilo. Okay, so we have to do the total surplus. So total surplus here, they're referring to the consumer surplus and the producer surplus at $8.40, right? So when the price has gone to $8.40, what is the consumer surplus and what is the producer surplus? And the total surplus would be both consumer and producer surplus. Let's go ahead and go back to the diagram and see if we can't figure out what those surpluses are. Okie dokie. So the consumer surplus, let's see if I can hopefully get this thing over here. Yeah. So that's going to be consumer surplus at $8.40. I hope you can see. So consumer surplus is going to be the area between the price and under the demand curve. So here the new world price is $8.40 and the demand curve is given by the demand curve. So yeah, and if we calculate the area, it's going to be half base time. So to get the area, it's going to be half base times height. And the base of this triangle is 90. And the height is going to be, you've got 12 minus $8.40. That is, what is that? Like 360, I think? Whatever. So let's go 12 minus $8.40. Right, so that's the height. Now, assuming we've done that correctly, rather assuming I've done it correctly, we're going to get this area, right? So half of 90 times the 12 minus 8.4, which is $162 million. So that's the consumer surplus at the world price of the new price of $8.40. Then to do the producer surplus, we're going to do something similar. Producer surplus, I'm going to get rid of this stuff over here. We'll wipe this out. Okay, now for the producer surplus, it's going to be the area. Their producer surplus is going to be this area over, it's going to be this area over here, this blue triangle. So again, producer surplus is the area above the supply curve and the market price. So if the price has risen to $8.40, that's a new price, then that's going to be the producer surplus. So again, we're going to do area equals a half of a base times height. The base of this triangle is going to be like 1,000, as you can see over here. Half of 1,000. And the height is going to be this guy over here, that distance. So it's going to be 840 minus 2, which should be like 560, I think. So we go 8.4 minus 2. It's whatever that is. So, let's go back down here. Yeah, it's going to be equal to area like Bij, the triangle, which is up there. And it's going to be a half of 1,000 times 840 minus 2. Which is going to be equal to 3.2 billion or 3,200 million US dollars. So the total surplus is going to be the sum of consumer plus producer surplus, so it's CS plus PS, consumer surplus is 162 million, and producer surplus was 3,002. So if I go 162 plus 3,200, we end up with a total surplus of $3,362 million. And so to answer the question, again, if you have space for it, it's good just to give like a little one sentence. We would say the total surplus is $3,362 million as a result of that price increase from US 520 to US $8.40. Cool. Let's move on. Okay, so part 6 of question 1. Using an international trade diagram, explain how an export subsidy could be used to increase the quantity of salmon exports from Chile. Okay, so it's 4-marker. Looking at this, you probably get a couple of marks for the diagram and another couple of marks for the explanation. So let me try to explain what I have done. Get this thing in focus. Okay. So here for the diagram, we use an export subsidy diagram. The way this is going to work is, okay, so as usual, you're going to set up your supply and demand curve as normal. Then we have this thing PW over here. That's going to be the world price before an export subsidy. Now, once we put an export subsidy down, what we're saying is, okay, whatever the world price is, we're going to whack on an extra subsidy on top of that so that effectively the price that the domestic producers are going to get is not the world price, but the world price plus some sort of extra subsidy on top of it, some sort of extra economic benefit. And so effectively what that's going to do is it's going to raise the effective price or the world price that producers receive from PW to PW plus subs, right? Whatever the amount of the subsidy is. Okay, and then what we can do is we can kind of trace out the effects of this export subsidy. So before the export subsidy at PW, domestic demand is going to be given by this level D1, and domestic supply is going to be given by S1, by the supply curve. And so the difference between the two is going to be your export levels, right? So you're exporting more than you did. Your export S1, your production or domestic supply S1 is going to be greater than your domestic demand, which is D1. So S1 minus D1, that excess is going to be equal to export levels at P1. Then what's going to happen is when we put on that export subsidy and prices go to PW plus subs, when effectively the price has risen, that's going to cause a reduction in demand. So demand's going to, so if I go to draw this out or something, let's go over here. So demand's going to fall from, let's say, D1 down to D2. And so the new level of demand is going to be equal to D1. And at the same time, the new level of supply is going to rise from, let's say, point A to point B. And supply is going to go from S1 to S2. And so now the new export level is going to be given by that difference, S2 minus D2. And you can see from the diagram, EX2, which represents the amount of export, is going to be bigger than EX1 because of that higher price that's given to us by the export subsidy. Okay, now, so all we're going to do is put all that in words. Okay. Here's what I have said down here. Before a subsidy, prices are PW, domestic demand is D1, and supply is S1. Exports are S1 minus D1 equals EX1. After subsidy, prices are PW plus subs, domestic demand is D2, and supply is S2. Exports are S2 minus D2 or EX2. And so with the export subsidy, prices rise from PW to PW plus subs. As a result, exports increase from EX1 to EX2. So yeah, that's about as clear as I can get it. I'll leave it to you how you want to explain that. But essentially, yeah, as long as your export subsidy diagram has like these main components, and as long as you have sort of, I guess a good way to do it is to sort of go before and after subsidy, and then talk about what the different export levels are, and then have a quick sentence just to explain how the export subsidy has actually raised the amount of exports. And yeah, that should be sufficient to get your 4 marks. Okay, let's move on to the next bit. Part 7. Salmon in Chile are bred in fish farms. some of these farms have been criticized for using large amounts of antibiotics. Although the fish are kept in ocean-based farms, chemicals and other salmon byproducts can spread. This threatens marine life in areas near the fishing farms and can lead to antibiotic-resistant strains of bacteria, which can infect humans, causing them to seek medical attention. Oh no! Some indigenous fishing communities are fighting for their traditional way of life. Salmon farms use the ocean, a common access resource, so intensively that there are far fewer fish available for local communities who rely on small-scale fishing for their livelihood. Okay, so part 7, define common access resource. All right, so there are 2 defining characteristics of a common access resource. The first is that they are rivalrous, meaning that if I consume it, that means you can't consume it because only one of us can. If my consumption means less of yours. And the second feature of a common access resource is that they are non-excludable, meaning I cannot prevent you nor can you prevent me from accessing or using that resource. Okay, so just need maybe a few sentences just to explain that. This is what I've got. So that's it. These are natural resources that are rivalrous. So just maybe explain that. One person's use reduces the amount available, but non-excludable. No one can be prevented from using them. This means that people can use these resources freely, leading to overuse and depletion. Yeah, or something thereabouts. So as long as you've got, yeah, so as long as you've got something like that, then you're good. But just mention, as long as you mention rivalrous and non-excludability, those, as I mentioned, are the 2 main features of common access resource, and just try to explain as succinctly as you can what these are. They don't give you a lot of space, which is really annoying, but I guess they're trying to sort of hint to you that you don't need to write an essay, just go to short and sharp and to the point. Okay. Anyway, 2 markers. That's a 2 marker. Let's keep moving. Okay, the next bit over here, which is part 8. Using an externalities diagram and the information provided, explain how salmon farming in Chile can result in market failure. Okay, so 2 things. First, you got to do the externalities diagram, which I will show you in a minute. You can already see it's down there. And also, you have to explain how that is going to result in a market failure. So we've got to get our market failure hats on. 4 marks for this question, 4 marker for this bit. So it's going to be probably 2 for the diagram and maybe a couple more for the explaining bit. All right, so this is our typical. Let me zoom out a little bit. So this is our typical, externalities diagram. What you kind of need for an externalities diagram is you always want to have obviously your demand and private costs. So the main things to draw are the marginal private cost curve, or MPC, and then your marginal social cost curve, or MSC. And the MSC is going to be above or sits above the MPC to represent the fact that with these types of market failures, marginal social costs are often typically higher than the private costs. And then you to have your demand curve or the marginal social benefit curve. All right, so then typically what you also want to indicate, you don't have to do this, but I've sort of also mentioned it at the side here. By the way, in case the examiners will know what you're talking about, but if you kind of just want to show off a little bit and demonstrate that you fully understand what's going on here, you can say, by the way, MSC stands for the marginal social cost curve and MPC stands for marginal private cost. Okay, and then you also want to depict sort of how if you leave it to the free market and you don't sort of correct this in any way, then what's going to happen is that demand is going to end up, the market's going to end up at the point where MPC is equal to demand, and QM or Q market, whatever notation you want to use. I'll just use QM. That's going to be the amount of consumption / production in under free markets. And then you also want to indicate that the socially optimal quantity, Q star, is often less or below the level of QM. Hence the fact that we're overdoing this essentially. Okay, so that's the diagram. Probably want to set it up properly. And obviously, don't forget to label your axes as well. So, price, quantity, all that good stuff. Dot your I's, cross your T's. Just kind of basic sort of common sense stuff. Then down here, we need to have a quick, maybe just a couple of sentences to explain how that is going to result in a negative externality. So here is what I've written. I have said the spread of antibiotics represents a negative externality. So so if you're pumping this stuff, these chemicals and these antibiotics into the ocean, it's not just bad for you, it's bad for everyone else around you as well, so it's negative externality. Therefore, marginal social cost is greater than marginal private costs. As farms do not face social costs, they will produce at the point where MPC is equal to D. The quantity that is produced is QM, which exceeds the socially optimal quantity Q star, resulting in overproduction and market failure occurs. Okay, so that's, again, that's about as short and sweet as I can get it to. You only have 5 or 6 lines or whatever to explain your position. So yeah, you need to be as efficient as possible with your explanation. Okay, I'll let you read this for a couple of seconds if you want to, but let's move on. Now, part B. Okay, so this is the 10 marker. So this is the big one. Using the text/data provided and your knowledge of economics, recommend a policy which could be introduced by the government of Chile to address market failure in the salmon farming industry. So here you just need to choose one policy, right? There's any number of things that we can use to fix a market failure. So for example, like taxes, regulation, quotas, you name it. There's plenty of policies that you can use to fix a market failure. Typically my go-to, I reckon so in terms of strategizing, you probably want to pick the one that is most easy for you to explain. Whatever that is, that's up to you, right? So for you, maybe you happen to know quotas really well, or maybe you happen to know regulations really well, whatever. For me, I think taxes seem to be one of the more easier ones to explain. So I'm gonna use that, right? So please don't feel like you have to use taxes, which is the solution that I've used. But for me, I think taxes are one which I think is easily explainable from kind of a point scoring perspective. That's the one that I'm going to use. Okay, but just keep in mind that there are other policies out there, not just taxes. There's multiple ways to achieve your objective. Okay, so here I've just started by saying, so by the way, when it comes to these types of explanations, you probably want to break it down into a couple of sections. The first section is you need to explain what the policy is, like what exactly does it do? And then the second bit is you probably want to apply and say, well, how does that specific policy fix or that market failure? Okay, so the first half is going to be the what, and the second half is going to be the how. All right, so what I've said here is, okay, so one solution is to apply a supply-side tax on salmon farmers. The goal is to shift the supply curve leftward, reducing overproduction and aligning private costs with social costs. Okay, so essentially what we're trying to do here is we're trying to say we need to somehow, the problem is caused by this fundamental misalignment between marginal private costs and marginal social costs. So we have to somehow realign these things. We need to somehow shift the MPC curve back to the level of the MSC curve. And so one way to do that is to use taxes, because that will help realign those two curves. So before tax, firms only consider private costs, for example, feed and labor and all that sort of stuff, excuse me, and ignore external costs, for example, chemicals and other byproducts. This results in overproduction at QM, see the diagram, where marginal private costs, MPC, are less than marginal social costs, MSC. So that's explaining the first bit over here, where we're saying that if you ignore this market failure, don't really do anything about it, then firms are going to be producing at the point where MSC equals MSB, or demand, and that's going to be over here, and we're going to end up producing QM, which is overproduction. Then, so down here, after tax, the government imposes a tax equal to the external cost per unit of output this raises the firm's cost, shifting the MPC curve leftward toward the MSC curve. The new equilibrium Q star is socially optimal, thus reducing the negative externality. So that's the explanation bit. Just get rid of this so we don't confuse ourselves. Oh no, we're done. Uh-oh. Okay, so what we're saying is once we put the tax on, then hopefully if the tax is effective, it's going to shift this thing backwards, and we're going to end up from MPC down back to MSC, and so the quantity that's produced and consumed will naturally fall from QM down to Q star. So that's the first bit. That's like kind of what the tax is going to do. The second bit is, I guess, maybe you can talk a little bit about theory and stuff. So a supply-side tax corrects market failure by forcing firms to bear the true social costs of their actions. Leading to a more socially efficient level of production. The tax discourages environmentally harmful production by making polluting more expensive. Firms have an incentive to adopt cleaner technologies to reduce their tax burden. So down to the next paragraph. If Chile imposes a tax on each kilogram of salmon produced, farms would either reduce production or adopt sustainable farming practices. This would reduce overfarming, pollution, and ecosystem damage. So again, just a bit more exposition, blah, 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 a bit more explanation. And you could probably just end it here, really. That'd be enough. So, but just as an extra little bit down here thrown in, I just want to show off a little bit. However, a portion of the tax we pass on to consumers in the form of higher prices. The tax incidence depends on the relative elasticities of supply and demand. So you don't have to do this part here. This is just saying that, the taxes, this is how the taxes work in theory, but in practice, what's going to happen is that instead of just taxing the producers, a portion of it is going to kind of leach off and affect the consumers as well. And that's what we call tax incidence, and who pays for that tax instance it actually depends upon elasticity of supply and demand. But I don't think you guys have done that yet, so you don't have to worry about that. So yeah, so if you just kind of maybe just do this bit here, the way I've done it, which is first of all explain what the tax is, like mechanically, like what does it do, and sort of refer back to the diagram. And then down here, if you just then kind of say, well, in principle, this is how the tax works, right? It corrects for the market failure by blah, 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 blah. Then, yeah, that should be sufficient to demonstrate your understanding. Okay, so that about does it. This is question 1, and I'm going to do question 2 in a follow-up video. So, keep your eyes peeled for that one. All right, thanks, folks. See you around. Bye.